All right, we're back. We are still working on choosing a factoring method. And sometimes it is often necessary to use more than one factoring method to factor a polynomial completely. So let's go ahead and see look at a few examples and see what they're talking about. So here we have 5x squared minus 5x minus 60. We're going to factor this completely and then check our answer. Okay, so what do we see? What do we see? Okay, we're always looking to factor out that GCF, right? Do you see a GCF? Yes, they all have a greatest common factor of 5, so we're going to factor that out. So 5, this is x squared, this would be minus x, and 5 times, is it 12? I think so. Yes, it is 12. Okay, now we're left with this. We would look for perfect square trinomials because we have a trinomial, right? This is a squared number, but this is not. So since there's a 1 here, we're just looking at the factors of 12 that have a difference of 1, right? And what are the factors of 12? Factors of 12, 1 and 12, 2 and 6, 3 and 4. 3 and 4 have a difference of 1. Woohoo! We know that that one's it. So we're going to go here. We're going to do our little voot, x, and 3 and 4. And I need this to be negative. First I know that to get a negative number, one has to be positive, one has to be negative, and I want my answer to be negative, so that means the bigger one has to be negative, so negative, positive. There you go. Now let's check it. So we keep this on the outside for right now. This is, what are we doing? X times x is x squared. The outside x times negative 4 is negative 4x. The inside 3 times x is 3x, and then 3 times negative 4 is negative 12. Then we simplify this, right? And we get negative x minus 12. And lastly, we just need to multiply all of this by 5. So 5 times x squared is 5x squared. 5 times negative x is negative 5x. And then 5 times negative 12 would be negative 60. So we're going to look and say, hey, is this the same? And we have 5x squared, yes. Negative 5x, yes. Negative 60. Woohoo, we did it right. So perfect. Okay, let's look on the next one here. It says factor completely. We have 16x squared minus 36. Okay, so first, right, we're going to look at the GCF. GCF. What is the GCF? What is the biggest number in common? Is it 4? What do you think? 4, other than 4 for 16 would be 8. 8 doesn't go in there. So yeah, I think it's 4. So let's go ahead and factor it to 4 first. So 4 times 4 is 16. Minus 4 times 9. Okay. So we have that. Now we have a binomial, right? So we want to check for difference of squares. Is this a square number? Yes. Is this a square number? Yes. Is this a square number? Yes. Is it a difference? Yes. It's a difference of squares. Woohoo! So we're going to go here, my little voot. I'm going to put the 2x here, 2x here, 3 plus minus, boom shakalaka. We are done with that one. Now we have to check it. So hold on. Excuse me. All right. So here we go. First, 2x times 2x is 4x squared. 2x times negative 3 is negative 6x. 3 times 2x is positive 6x. And 3 times 3, that's negative 9. Okay, those cancel out, which is lovely. And what do we have? 4x squared minus 9. And then we have to distribute this 4. 4 times 4 is 16x squared, and 4 times 9 is negative 36. So, is this the same as this? What do we have? 16x squared minus 36, and yes, it is correct. Woohoo! All right, so now it is your turn to factor each polynomial completely. So I want you to try 4, 5, and 6. Where's my friend? Where are you, my friend? Here's my friend, the pause dragon, reminding you to pause your device. Work out 4, 5, and 6. When you get done, press play and we'll talk about them. All right, see you in a bit. Okie dokie, let's see how you did. So first thing, greatest common factor. Is there a greatest common factor here? Yes, 3. 3, so we got to factor that out, right? 3 times x squared is 3 times x squared. or 3x squared. 3 times 100 is 300. Okay, now we have a binomial, so we're checking for difference of squareds, right? Squared number, yes. Squared number, yes. Difference, yes. It's a difference of squareds. So we're going to get a little voot-voots. This is x, this is x. 100 is the same thing as 10 squared, so we go 10 and 10, a negative number. So one has to be positive, one has to be negative, and there is your answer. If you got that right, great job. Okay, let's look at 5 and see how you did. First thing we're looking for is that greatest common factor, right? Is there a common factor here? Yes, 4, right? 4 goes in here, 4 goes in here, 4 goes in there. So let's factor it out. 4, this would be x squared. 4 times 5 is 20, so negative 5. And 4 times 6 is 24. Okay, now we have a trinomial, so we're going to look for that perfect squared trinomial. Squared number, yes. Squared number, no. Okay, so then, since this is a 1, we're just looking at the factors of 6 that have a difference of 5. And 6, it would be 1 and 6. That is a difference of 5, so that's going to be it. So we go x and x, we go 1 and 6, and we need a negative 5. First, we know this is a negative. So one has to be positive, one has to be negative, right? With that said, this is a negative, so that means the bigger one has to be negative. So the 6 is negative, the 1's positive, and there we have it if you got that one right. Great job. Okay, let's move on to the next one right here. The next. Okay, greatest common factor, right? That's what we're looking for first. What is the greatest common factor here? 8, 6, okay. What, 2 is a common factor. Is 4? No, 4 doesn't go in there. And 8 goes in there, but not there. So it's going to be 2. So we factor out a 2. We get 4x squared, 2 times 20. So yeah, 2 times 4 is 8. 2 times 20 is 40. And then 2 times 25, positive 25. Okay, perfect. Yeah, that looks good. Looks good. Okay, trinomial, and we're looking for a perfect square trinomial, right? Squared number, yes. Squared number, yes. Squared number, yes. Ooh, got to check this one, right? So this is, what's this going to be? This is going to be 2x. I'm going to write on the top. This is 2x, right? Squared. And this is the same as 5 squared. So this middle number is going to be 2 times 5 times 2x. So 2 times 5 is 10, times 2 is 20. So we got it. Woohoo! All right. All right. So we're going to do my little voot-voots. It's going to be 2x here, 2x here. 2x times 2x is 4x. It's going to be 5 here and 5 here. And we know both signs have to be positive or both have to be negative, and it's negative, so this has to be negative. And then I'll just rewrite it as this. And that's it. That is our answer. If you got that one right, awesome. Okay, let's do a couple more problems. So I want you to try this. 7, 8, and 9. 7, 8, and 9, 7, 8, and 9, 7, 8, and 9. So here's my friend the pause dragon. Remind you to pause your device. Go ahead and work out 7, 8, 9. When you get done, press play and we'll talk about them together. All right, see you in a bit. Okay, we are back. Let's see. Ooh, okay, we're looking for greatest common factor, right? Greatest common factor. Is there a greatest common factor here? I would say yes, 7, right? 7 goes in there, 7 goes in there, 7 goes in there, but there's a negative in front of that x squared, so we have to factor out a negative 7. Ooh, this is going to be interesting. So we put negative 7 there, and it's going to be x squared, and then negative times a positive is going to be a negative, and 7 times 3 is 21. A negative times a negative is a positive. All right, we need a positive. So negative times a negative is a positive. 7 times 4 is 28, so we put a 4 here. And yeah, that's that part. Now we're looking at this for a perfect squared trinomial. It's a trinomial. This is a squared number. This is a squared number. But for a perfect square trinomial, this has to be positive, and this is not positive. This is negative. So this is not a perfect square trinomial. Yeah, so this is 1 in front of here. So we're basically looking at the factors of 4 that have a difference of 3, right? And we know that's going to just be 1 and 4. so we're going to do our little voot-voots. We got x here, 1 and 4. And we know that to get a negative number, one has to be positive, one has to be negative, and we want a positive 3, so that means the bigger has to be positive, and the smaller has to be negative. And if you got that one right, great job. Okay, let's look at the next example. We have 8x squared minus 18, right? So we're looking for that GCF. I'm going to say that 2 goes into both of those, right? 2 times 4x squared, and then negative 2 times 9. So we have a lovely, what is this? A lovely binomial. So we're checking for the difference of squareds. Squared number, yes. Squared number, yes. Squared number, yes. Difference, woohoo! So difference of squareds, boom, boom, voot, voot. We know it's going to be 2x, 2x. The 9 is the same thing as 3 squared, right? So 3, it's a negative, so one has to be positive, one has to be negative, and yes, that is our answer. Okay, let's go ahead and look at this next one here. I'm looking for that GCF. It looks like a 10 goes into all these, so let's factor out a 10. That would be 2x squared plus 5x plus 3. We have a trinomial, a lovely trinomial. We'd look for what would we look for? A perfect square trinomial. That is not a squared number. So we are just looking at, since this is not 1, we're looking at the factors of 2 and the factors of 3 that add to 5. Okay, that's going to be fun. So factors of 2, let me do my little voot voot action. Voot 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 voot. Factors of 2 are just 1 and 2. There's only one option, which is nice, right? So I'll just make this 2x and x. And then factors of 3 are just 1 and 3. Ooh, there's only one option here. So this is my first, right? Okay, so, right, this is my first. This is my last, this is my outside, this is my inside, and we're adding the factors of the outside and the inside to get this middle number, right? So this is my first, okay, and it has to be, I'll put this 2. It has to be 2 and 1, right? And then there's 1 and 3, and so we can either go across or multiply. And if we go a diagonal, 2 times 3 is going to be 6, and that's going to be over 5. So it's going to be too big. So I think we're going to have to go across, which would be 2 times 1 is 2, 1 times 3 is 3, 2 plus 3 is 5, which is what we need. So that's it. So this 2 and 1, that's on our outside, right? So the 2 goes with the 1, and then this 1 goes with the 3. So the 3 is here. And then either both the signs have to be positive or both have to be negative, and they both have to be positive. So that is our answer. If you got that one right, great job. Okay, on to our last 3, 10, 11, and 12. And I want you to go ahead and work these ones out. Where's my friend? Where's my friend? Where are you, friend? Here's my friend, the pause dragon. Remind you to pause your device. Go ahead and work out 10, 11, 12, and then we will go over them together. All right, see you in a bit. Okay, we're back. Let's see how you did on 10. These ones are so fun. Okay, these ones are a little bit more challenging. Okay, so we are looking for greatest common factor first. And yes, the greatest common factor is x. You should have factored that out. That would have left us with x to the 4th minus 1. Okay, then we're looking for, we have a binomial, so we're looking for difference of squares, right? So is this a squared number? Yes, this is the same thing as x squared squared, right? Because the power rule, 2 times 2 is 4. And then 1 is a squared number because 1 is the same thing as 1 squared, right? And is it a difference? Yes. So we have a difference of squareds. So it's going to be this. We're going to do a little voot-voots. And this is going to be, we put the x squared and the x squared here, and the 1 and the 1. And then it's a negative, so one has to be positive, one has to be negative, right? And so there we have this, right? We factored our x. Okay, do we have, and then we always want to look at it, right? Is this a squared number? Yes. Is this a squared number? Yes. Is it a difference? No. So this is factored completely here. Is this a difference of squares? I mean, is this a difference? I mean, we have a binomial, right? Is this a difference? I mean, is this a squared number, Joy? What are you trying to say? Is this a squared number? Yes. Is this a squared number? Yes. Is this a difference? Yes. So this is actually a difference of squares. We can factor this further. And so you always want to look for something like this, right? That has that squared number, because even though you did it once, you're not done. This is a squared number. This is a squared number. This is a difference. So we can go here, and then we can do another voot-voot. X, X, 1, 1, plus, minus, and now there's nothing further that we can factor, so we are done. And that is our answer. Wowie kazowie, that was a good one. Okay, let's look at the next one. So if you got that one right, great. If you didn't, go ahead and change it. So yours looks like mine. Okay, let's go ahead and look at this one. So we're looking, what are we looking for? We're looking for common factors, right? And A, there's a common factor A, so we're going to factor that out. And we're left with b to the 4th minus 16. Okay, that's wonderful. Then what do we do? Okay, so it's a binomial, so we're looking for a difference of squares. Is this a squared number? Yes, this can be written as b squared squared, right? The power rule, 2 times 2 is 4. Is this a squared number? Yes, this is the same thing as 4 squared, right? And is this a difference? Yes, so we can write it as a difference of squares. So we can go A times, and then we just go, I need my voot-voots. This would be b squared, 4, and 4. This is a negative, so one has to be positive, one has to be negative. Okay. So now we're going to look, right? That's good. Okay, this is a binomial. Is this a squared number? Yes. Is this a squared number? Yes. Is this a difference? No. So that's factored completely. Let's look here. Is this a squared number? Yes. Is this a squared number? Yes. Is this a difference? Yes. So this can further be. So you really have to look for this, right? Because we can factor this more. It can be factored more. So we have to do it more. So we're going to rewrite all this other stuff, right? A, b squared plus 4, and then just voot-voot. We go b, we go b, we go, 4 is the same thing as 2 squared, so 2 and 2, and then we need a plus and a minus. And that is our answer. Perfect. Okay, so if you got that one right, awesome job. If not, go ahead and fix it. So let's look at this last one here. This last one. So what do you see? I see 1, 2, 3, 4, right? But the first thing we want to do is look for the GCF of everything. Is there a GCF of everything? 5, right? 5 goes into there, 5 goes into there, 5 goes into there, 5 goes into there. So we can factor out of 5. So let's do that. Factor out of 5, which is going to make this 8x cubed minus 12x squared minus 2a plus 3. Okay. Okay, we factored out the GCF. Now we just want to look, right, at these first two terms. So there's 4, so we want to try to see if we can factor by grouping. So what would be the common factor there? So I'm going to rewrite this 5. Actually, I'm going to kind of use these brackets, okay? I think there's a 4 that goes into both of theirs and an x squared. So it's going to be 4x squared. And then this is going to be 4 times 2x and 4 times 3. And this one here, oh no, this is supposed to be an x. Okay, change this. This is supposed to be an x. I misprinted. Change this to an x. I messed up. This is an x. Okay. So on this one, let's see here. This looks very, very familiar to this, but the signs are wrong. This is a negative, this is a positive, this is a positive, this is a negative. So when that's the case, we can just factor out that -1, right? And that's going to, -1 times a positive 2x is going to give us that negative 2x. And then a negative times a negative is going to give us that positive 3. Okay. All right. This one's a good one. Okay. So then what do we see? 2x minus 3, 2x minus 3. That's in common, so we're going to factor that out. So we have 5 multiplied by 2x minus 3. And then what's left, right? 4x squared minus 1. Put the bracket. Okay. That's good. I don't really think I need this bracket anymore. I can just write the 5 on the outside. So this is factored completely. What about this? Ooh, this is what is this? A binomial, right? Is this a squared number? Yes. Squared number? Yes. Squared number? Yes. Difference? Yes. So we can factor this. So I'm going to write 5. I'm going to rewrite this 2x minus 3. And then I'm going to do my voot-voots. And this is going to be 2x and 2x and 1 and 1. And the only way you get a negative number is one's positive and one is negative. And that is it. Holy goodness, that was a tough one. If you got that one right, great job. Well, that is it for this lesson in this chapter. I'm so proud of you. You're doing a great job, and I will see you next time.